Hi, I'm Tommy. Today's lesson will align with the above standard. In doing so, we're going to talk about the relative brightness of stars, their composition, and how Earth's position might play a factor in the relative brightness. Thank you and enjoy. Let's take a minute to discuss our closest star, the Sun. It's a relatively common star. It's not unlike many others in our universe. It's middle-aged, is comprised of many elements, and it's 93 million miles away from Earth. Very interesting facts. Let's continue. Scientists use a spectroscope to determine what a star is made from. This spectroscope is nothing more than a prism that spreads the light out into a spectrum of colors, like a rainbow. These colors tell scientists which direction the star is moving, what temperature the star is, and how bright it is. The temperature also affects the color of the star. Now I'm going to show you a spectrum that I took of the Sun. This is a photograph of a spectrum of the Sun that I took using diffraction grating. Diffraction grating is like hundreds of tiny prisms attached to a sheet of film. The sheet of film screws into the front of an astronomical camera. This grating can be analyzed to tell scientists what the stars are made of. This is that same spectrum that has been processed and analyzed. I did this myself using specific software. There are different dips and peaks in the spectrum that represent different elements. The ones that I just pointed to are hydrogen. They have a very distinct signature. And this tall peak, that is sodium. That gives the Sun its yellow color. Just to give some meanings to these terms that I've just thrown at you, I want to show you a couple of things. The first item is the camera I used to take the spectrum with. Notice there's no shutter on this, just a couple of USB ports. No lens. The lens is the telescope with this type of camera. And also, I like to show you the diffraction grating. If you look closely, you can see how there's a slight rainbow pattern on the lens. This is because there are those hundreds of tiny little prisms that I just told you about. This is what we use to measure the spectrum of stars. Okay, now let's wrap this up. We talked about the spectrum, how scientists use it to determine what the stars are made of, what the temperature is, and how that temperature affects color. All of that contributes to the apparent brightness. The apparent brightness is how bright a star is as seen from the observer's position. And our position just so happens to be Earth. The Sun, being our closest star, appears to be the brightest. But in absolute brightness, the Sun is just an ordinary star. There are many other stars that are brighter than it, and there are many other stars that are much dimmer. That is determined by the color of the stars and the temperature, like we just discussed. Now I want you to take this information with the materials at your workstations, and I want you to assemble some posters. Your posters should document how the stars are measured and why the apparent brightness changes depending on the observer's position. Why are some stars brighter than others? Thank you. Have a good day. Bye-bye.